Okay, hello, Rebecca and Christoph, and Fabio here. My program is image processing kernel program, and about the requirements, what I can tell you about if it's a complete new code, not, it's partially new. I got some few reference from the processing website, processing reference website, and some of the code also provided by Rebecca's in the I don't remember now. Let me check. And the week 15. Uh, how to use the program? You go through seven different images. All these images were intentionally selected. I will explain later why. To go through these images, you press the keys 1, 2, 3, 4, 5, 6, and 7. And to apply different filters, you apply all the keys on the keyboard except for B, N, and M. So we have a lot of keys that we can press. I will just run a little bit, then you can see a little demonstration. So I select the first picture is mainly red. I want to show some effects. Some kernels has some different effects in colors like red, and some different effects in colors like green, some different effects like in colors like blue. So I have the three first pictures mainly red, green, and blue. I also have this picture because this is a secondary color, it's not one of the main. And we have here a structure, construction here that we can contrast with some of the effects that we will see later on when we apply some kernels, when we convolute some matrices. I have this one. This is a very colorful one. We have almost every color here. We have yellow, we have green, we have some blue, and this is not, we have some red. This is not red, but this is a secondary color. It's purple. And this is very good because we can see very different effects depending of the kernel that we apply. We can see different colors for each. Then 6, this is Albert Einstein. I like this. 6 minus 3 equals 6. Yes, it's true. Is a black and white image. And some kernels, they have almost no effect in the black and white image, and I'm still trying to figure out why. And some of them are very simple. The result is just like the other ones. And this is another one because why I want the Alpha Eiffel Tower here, because this structure we can see when we apply edge detection, we can see just like a frame, a wireframe of the Eiffel. So this is what I want to see. Also, if we press the key V on the keyboard, we basically we multiply we multiply the image, every pixel of the image, by a kernel that doesn't change the image. And we can see where is my assistance here? This is the original, that's the default one. Okay, so I have some of the default, some of the kernels. The kernels I understand as well. You correct me if I'm wrong in my feedback, as an impulse response system, where we put some input. In this case, we're gonna put every pixel by pixel in the image that we are collecting pretty much here. We are going through this for loop to go for every row and every line. Okay, I think this is the row, this is the line. Anyway, so we use this because when we where is it? Here. When we load the image to this array, it's actually a one-dimensional array, and the image is a two-dimensional array. So For every we need to apply this formula, of course, for exposition, and then in the one-dimensional array, the location of this y is multiplied by the width of the image. So in this case, we can manipulate the whole thing, the whole image. But in this case, yeah. So here's actually not here. Here, sorry. This is the array. Of course, this is not an array. Well, and then here we take some pictures. We take some pixels, and then we send this pixel to the convolution, and the convolution will make the magic. Let's take some parameters here. It's all described in the comments. I try not to get too much in detail, or not in detail, not to spend too much of your time. Here, whereas the convolution actually, the mathematical convolution happened, right? And then I return the transform value of that pixel to its color. I have some here that I have some kernels I take as from the reference and from the Rebecca's code. Some of them I found on the internet, and some of them I did myself. For example, the gradient here I found on the internet, but the mixed gradient I did myself to see what happened. Sharpen 2, for example, I did myself to see what happened. There's one blur that I'm not sure where is it now. That is anyway, it's my, so all the references, to do this work, it's here. Everything that I checked to do this work. So what I'm doing with each image is I go through every pixel of the image, right, and apply the system, in this case the kernel, and the kernel will convolute that input and will give me a different output, and this output is returned and stored in this little window. So I will start to show, for example, some of the features that I'm applying. For example, this is probably we cannot see probably in the video. Maybe if I go, yeah, there is a little blur here. That's why this object is here. Now, of course, we have a very strong blur, and then we apply some other different. Is a blur as well, more blur. And apply some different, this is up, I think up 3, shift up, and let's go back to this one, and then we do some more of the, this is one of mine. Let me go to the Albert Einstein. So for example, here we have a very interesting contrast. Here, this is one of the things that's why I have a black and white image, because this filter, for example, it just recognizes very dark stuff, pixels, and I'm trying to figure out why. And then some of the other filters, and here now I press V. When I press V, I go back to the original one. So let me check the requirements if I'm forgetting something. I think that's all for now. Thank you very much, and I wait for your feedback. Thank you.